waste another day, eyes on my display. You say we need a change, and I feel that you mean it. You mean it. But you're so right, we're losing track of time, buying things online, and it's not like we need them. We don't need them. So can we just slow down? The only thing I'll do is lay here next to you. We need to slow down. Embrace the love we found. For you and I are safe and sound.
So, let's do this again. This is gonna be my third attempt at recording this. So, let's go ahead and go over the specs of this system. So, we've got an Intel Pentium. It's supposed to be a 90 megahertz Pentium, but it's overclocked by 10 megahertz to approximately 100 megahertz. Just so then I can keep the 66 megahertz front side bus speed. I don't know why it's not being detected there, but yeah, there's the 100 megahertz. We've got 8K of L1 data and instruction and 512K of L2 cache. Our motherboard is the AOBin AX59 Pro. Once again, I'm not entirely sure why the fields are kind of weird like that, but whatever. And we've got 256 megabytes of just some random SD RAM. I can throw an image of that on screen real quick. And then for our graphics card, it's a Voodoo 3, if I remember correctly, Voodoo 3 2000 or something like that. I don't remember the exact details, but for that, we can go into hardware info. Quick. Hardware info 32. And I'm just going to go ahead and skip IDA 64 because, you know, hardware info kind of covers most of that already. So we'll wait for that to start up. Taking sweet, sweet time. There we go. Alright, so, yep, I was correct. It was a Voodoo 3 2000 with 16 megabytes of SD RAM. There's the core and memory clocks there. There's our motherboard once again. And there's our Pentium once again. Just close that. And we'll just quickly run through things. We've got our Pentium as mentioned. There's everything that's there. We don't have any audio sources connected because I didn't want to bother with the fact that this board, or the Ryze MP6, does not seem to like my preferred sound card, which is just a Yamaha XG thing. Okay, there's that, there's that. There's more details there, including the VBOS version. And I can also probably pull up the driver version that I'm using as well. So let me just go to properties real quick. Settings. Advanced. There we go. 3DFX Tools version, adapter info, and there's driver. Ignore the release date. That's the install date of the driver, not the actual release date. So there's the driver version that I'm using. It's just the latest version off of Phil's Computer Lab's website. And yeah, everything else beyond that is just set to whatever happens to be default. Okay, so I guess just as a kind of preliminary run to start us off, we can go ahead and run a quick benchmark on this Pentium. We don't need a memory benchmark, we'll just do the CPU stuff. All right, and here's our scores. So I'm not quite sure why we have not applicable for the CPU benchmark, but I guess maybe the processor just does not support whatever features that hardware info wants us to have. So, without further ado, let's go into the rest of the benchmarks. Starting things off with CPU-Z, we get an integer score of 137.7 and a floating point score of 571.9. Interestingly, this is a little bit higher than the reference scores that CPU-Z has saved for an identically clocked Pentium. I'm not really sure what's going on with that, but it could be something chipset related. Moving on now to SUPERPI, it takes 14 seconds to calculate 16,000 digits of pi. Not bad at all, given the age of this thing. "3D Mark 99 Max scores a grand total of 456 3D marks and 635 CPU 3D marks. I'll let you see exactly how that came to be for a bit. Originally, I was planning on rendering a relatively complex scene with many different materials in Blender for a more comprehensive torture test. But for purposes called I don't want to sit and wait for several hours per CPU to finish, though, we're just gonna go with a basic cube render instead. So, moving on now to actual gaming, we've got, of course, classicube, Minecraft, Unreal, and MDK. On the Windows side, at least. So let's go ahead and run classicube. So this is a version of 1.3.6 that is compiled specifically for Windows 9X. And unlike the regular 32-bit versions of classicube, it does not need the CMOD instruction. So we'll go ahead and go into single player. I've already downloaded all the resource files that it needs ahead of time before I transferred it over to this computer. Let it load. And here we go. Ignore the white blocks of text in chat. I don't know why it's like that, because chat actually works normally. But yeah, it's clearly not happy with the 100 megahertz Pentium, considering how our highest FPS that we've seen so far was about, yeah, 2 FPS right there. So if you want to see the options real quick, there's our option. We've got normal render distance, block physics on, doesn't matter what we have for sound, no FPS limit, and view bobbing. So it's gonna attempt to navigate the world a little bit, which is not exactly easy to do when you've got so few frames to work with. And I'm not particularly worried either about using the exact same world for each CPU, because the world itself is generally quite small, especially given that it's classicube, and we've got the classic world side. Whoa, why did our FPS shoot up like that? That is much smoother now all of a sudden. Okay, drop back down. Oh, okay. I think what might be happening is, yeah, the transparent textures on the leaves are screwing us over. Okay. Well, I guess I will go ahead and save this world to a file that then we kind of have a reference for exactly what things are going to look like. So I'll go ahead and save. And I'm going to save it to a file. It's going to save that to desktop. Should be there. Yep, it is. Okay, so that's saved now. So when we're not looking at anything that can cause us intense lag, looking straight up in the sky, we've got about 13 FPS. Looking at the horizon with the water, we've got about 7 to 8-ish. Occasionally spiking up. I don't have fraps or anything installed right now, so I'm just going completely off of the in-game FPS counter. And when we look over at the terrain, that is when our FPS drops down to about 1 FPS. So I'll turn back over to the water here. And that's going to be it for classicube. Next up, we're going to go ahead and launch Minecraft. So we've got this batch file that I put together that I'm pretty sure that I've used in previous videos before, where it's just a very, very basic version switcher that wraps around the old Minecraft launcher. We're going to be using a version of Minecraft Classic that's technically labeled as InDev, just that then we kind of have feature parity with classicube, although this version of InDev also happens to be the one that has those fancier models that just kind of float around. So, yeah. Give it a moment while it launches. still not done yet. And there we have it, at long last. Let's go ahead and also enter the options here. I swear I had the FPS already enabled, but guess not. Come on. Either way, it's pretty obvious that performance is very, very, very lacking. So let's go to options. Slowly. Slowly. Show FPS. And there's the rest of the options for you. Whoa, 0 FPS? Who could have seen that? And now just painstakingly trying to get back to the game. I want to try and find an area with some water nearby, just like before. But then we kind of have something similar as far as the landscape goes. Come on. There we go. Walk forward, please. As you can probably tell, Java-based games do not run well at all on a 100 megahertz Pentium. Especially ones as complex as Minecraft. I'm sure that those like very small Java applets that used to run on flip phones and such would have fared much better than this. Alright. I think I should be able to just walk in a straight line from here. Hopefully. Please. There we go. Up and over, please. Up. Whoa, I'm jumping. Kind of. Okay, I'll attempt to stop when I'm roughly on that cliff there. And just like with classicube, I'm also going to save the world file. Although, I do think it might be interesting to throw up like a timer on how quickly it takes to actually generate a world. Okay, and we will stop right here. So our FPS does seem very, very slightly better here in that it is not like several seconds between frames. Let's try turning around now and see if that's still the case once we look back on the rest of the landscape again. Yeah. Yeah, it's just like classicube. The moment I start seeing some transparent textures such as leaves, that is when the frame rate drops like a rock. Okay, let's turn back over to here, where our FPS is just a little bit higher. Okay. Once again, we'll save the world. Oh, I guess we can't save. Never mind. I'll rip that idea. Okay. Well, there's your performance figures we saw about 1 FPS. Yep, right there, while we're staring off into the distance with nothing else visible in the terrain. Actually, let's unpause real quick. Yeah, about 1 FPS when there's nothing to see. Okay. Well, can't save that world. Alright, and we'll move on to Unreal now. We're just going to run the built-in time demo for Unreal. And it should be using Glide through the Voodoo 3. And if not that, then honestly, I'm mostly interested in the CPU benchmark. So as long as it's consistent between runs, as far as settings go, I really don't mind all that much. If it's actually using Glide or not. Could be using, I don't know, OpenGL for all I know. Anyway, let's start the time demo. Okay. So we'll take the second cycle. Actually, we'll let it run for 3 cycles, just that then we have kind of more averaged out ultimate FPS, I guess. And we do have something that's kind of like a 1% low, but not really. It's whatever. You can probably tell that I am not like a very, very accustomed to benchmarking. Oh, there's our FPS for that run. We'll see if it changes on the second one. Main reason why I want to do multiple runs is because when I start the time demo, I do have to interact with the keyboard a little bit, and that could potentially interfere with the results a little bit. And especially with a system like this, you really want to just squeeze out as much performance as you possibly can. Okay, we're getting close to finishing our second cycle now. Okay, there's cycle 2, and we actually had a slightly lower FPS. And we're just about to see the results of our third cycle. And there we go. So each cycle was actually a little bit slower than the previous one. Let's quit the game now. And last but not least, for the Windows side of things, we've got MDK, which just happens to be another game that happens to have a built-in benchmark. And at least personally, I've heard that it is moderately brutal on the FPU. So yeah, we'll go ahead and use this. We'll see Quake on the DOS side of things. But on Windows, you'll notice that our FPS is actually considerably lower than expected, matching or actually very slightly under the score for a Pentium 90. And that is literally just because Windows 98 is eating up resources. It's OS bloat. So I'll let this run for until about 30 seconds. 9:30, and it looks like we have stabilized roughly around 38-ish for our score. 38 what? I don't know. 38 FPS maybe? 38 points? 38 marbles? But that's it for our Windows tests, so we'll go ahead and restart into MS-DOS mode for our next ones. Okay, so restarting into DOS mode using Phil's restart in MS-DOS mode shortcut thing, we've got this menu. So we're just going to stick with conventional memory only, so then we don't have anything potentially getting in the way. So see all that there. I've commented out K6 in it since we're not using a K6 right now. And we're going to go into DOS things. Actually, let's go ahead and start with MDK. So you'll see here in DOS mode that it runs much better than it does on Windows. And there we go. We've got a result that's much more in line with what we're expecting for a 100 MHz Pentium. Technically, as mentioned, a 90 MHz Pentium overclocked to 100, but whatever. It is sitting right between the Pentium 90 and Pentium 166 for our performance. And once again, we'll let it run until 30 seconds. It looks like we're roughly around 50, 51-ish. We'll grab that now. Now we go into DOS Bench. Okay. And we'll go along with the benchmarks all for the faster PCs since we're using a Pentium 100 as our baseline. So we'll start with 3D Bench 1.0C for faster PCs. And we've got a score of 89.6 frames per second. Now we'll go on to Chris's 3D benchmark at 640 by 480. And we've got a score of 40.4, which translates over to 24.2 FPS. Now we'll do PC player benchmark at 640 by 480. And one thing I will note, just kind of off topic, is that under DOS, it does appear that it's a little bit outside of the bounds of what's being captured by the screen recording on both the left and the right. You can see the text being cut off a little bit there. Okay, so got a PC player benchmark score of, let's see, 12.8. So there's that. Now we'll go ahead and do Doom max details. And like, the whole thing about it being cut off on the left and the right isn't even consistent between benchmarks since everything is kind of doing its own thing. It looks like Doom is running pretty well. Okay, and that's an FPS of 52.12. Now we're going to do our quick time demo at 640 by 480. So this is the benchmark that's probably going to make quite a few CPUs struggle, especially given how FPU heavy it tends to be. You can already see that the Pentium isn't doing that great either, given that it's, a 100 megahertz thing. Normally you would not be running Quake at this resolution, I'd imagine. But I want to stress things out. I guess I'll run a lower resolution version of Quake as well after this, just for kind of a frame of reference. That's 9.6 FPS there. So I gotta step away for a moment. I will continue recording in a moment. All right. I watched my little puppy. Anyway, let's go ahead and run Quake at 3. And let's just run the regular Quake time demo. So option C, I believe this is going to be 320 by 240 most likely. Yeah, this looks like 320 by 240. And yeah, that is a whole lot faster than it was at 640 by 480. Okay, 28.3 FPS. But out of that, now we're going to run pretty much just everything else aside from the cache check stuff. So system information, next, or actually, B, benchmarks, CPU speed, 316.6 on the computing index. Then L for landmark speed test. Formed like a 802 megahertz AT. Clearly it is misdetecting things. Okay, after that, we're gonna put top bench, and we have a score of about 292. Yeah, that's fine. And last but not least, speed 6, 4.78. We've got a score of 74.75 on our CPU benchmark, which is in the ballpark of what we're expecting to see. Just doing a memory test now. Okay, so now we can definitely see the cache performance going there. We've got a roughly 8K boundary on our reading benchmark, and another one at 512K, which is definitely expected given the cache setup of the Pentium itself and the cache on the board itself. Interestingly, writing does not appear to be all that affected at all. So, given that the AOPEN X59 Pro that I have is a 512K cache model, that does mean that it is stuck permanently in write through mode, even if I set the cache configuration to write back in BIOS. So, just as a very brief explainer on that, that means that anytime we want to write back to memory, instead of just writing to cache and then letting the memory controller handle the write back to memory after that, it has to write to cache and to memory. And so as a result, that writing benchmark is pretty much going to be constant because we are stuck with the system memory speed. In other processors that have other cache configurations, I think it might be possible for the writing benchmark to be quicker. Like we might actually be able to see the figures for it, other than besides just a flat line, but I don't think that the Pentium is it's a flat line. You cannot see any difference whatsoever. Okay, anyway. Uh let's go ahead and get PCI info, memory info, and let's make a report. Comments, the P54C, megahertz, save as 100. Yeah, okay, P54C 100. Okay, and exit. And that is the last of our DOS benchmarks. I'm gonna put back to DOS now. And yeah, that's a lot of old files. So we're gonna start at P54C 100 and just regenerate the files from there. But aside from that, that's it for our benchmarking. Let's go back into Windows now. And yeah, hopefully editing works a little bit better for me with these shorter clips, because I have been recording these benchmark for Windows separately, and DOS benchmark is just a block. And yeah, hopefully video goes up soon. Let's wait till we get back up to Windows. Look at that, it's done to run K6 in it. And yeah, I used to have the Yamaha sound card installed, and that's why there's Set Blaster there. And the Windows 98 boot screen is currently disabled as well, so it's just sitting there. And we are back in Windows 98. And I guess to an extent we do have a moderate amount of bloat, as you can see in the system tray there, because the system monitor thing, that's a AOPN utility for monitoring heat and the voltage and stuff. Anyway, yep, that's it. Thanks for watching, and I'll see you in the next one. Bye.
In front of us. So can we just stop?